All right, everybody, I'm going to do these last two pages kind of as one video. This one will go pretty quick, and the last ones are just kind of multiple choice talking about them. So this will be questions 8 and 9. So we have a complex circuit here. Again, not series, not parallel. It's actually resistors 2 and 3 are in parallel with each other, and then together they're in series with resistor 1 and resistor 4. And again, I know that because the way I watch the current kind of let's get that out of here. How I watch the current flow out of the battery. All of it flows through R1. It splits before it goes through R2 and R3, and it comes back together, and all of it goes through R4. So the current path is R1, then 2, 3, then 4. So anyway, we'll just jump right into it. It's a circuit Sudoku one. So we know R1 is a voltage of 16. So I like to put a little thing across the top and call that 16 volts. And it tells me I have 4 amps through that. All right, we'll come back to that one. That one's going to be, that's a lot of information right there. I mean, just because that's the single one, I know the flow. I can see that I have 1 amp through R3. And that's all I know. I know the resistances of the other ones, but that's it. So I don't know the total. I don't know anything. So the first one I'm going to do is go ahead and just solve the resistance there. 16 divided by 4. So 16 divided by 4 is 4 ohms. That's pretty easy. All right. And that gave me a 16 volt drop. So I'm done. That's all I can do unless I go back and analyze the circuit. So I'm going to switch over to red. Red tells you I'm thinking about current. So I know if 4 amps is through here, that is the current in that branch right there, or in that first line, 4 amps right there. So that's the total current, 4 amps right there. Now, that doesn't help me get to the voltage at all, but it is one I can fill in there, and then I can follow that around. Well, I see it split, so it goes this way and this way. And so I don't know the voltage, or excuse me, the amps right there, but even though it splits, I know one of those currents is 1 amp, right? That's the 1 amp that's flowing around this way, going through R3. So I know the other current has to be 3 amps. So 3 amps. So the current that goes through R2 is 3 amps through 3, and that allows me to find that voltage. So 4 times 3, get voltage in blue, 4 times 3 is 12 volts. So I have a 12 volt drop across R2. All right, and then let's stick with current. Current's then coming back. Both those currents come back together in this node. So the 1 amp from this side and the 3 amps from there come back together to produce 4 amps again. And so that's 4 amps going through R4 as well. And then back to the battery. Now, we can find the voltage there. 2 times 4 is 8 volts. So I know I have 8 volts right there. So the only one I'm stuck with is this R3 here. Because I don't know a resistance of it. All I know, there's 1 amp flowing through this random thing. I don't know what anything else. But I do know that in parallel, voltages are the same, and R2 and R3 are in parallel with each other. And so if it's 12 volts across R2, then it is 12 volts across R3. So that would be 12 there. 12 divided by 1 is 12 ohms. That's it, right? Nope, still have the total. So how the heck do I figure out the total voltage? Well, this is the voltage law, the loop. So you can pick either loop. I can go R1, R2, R4 back to the battery, or I can go R1 plus R3 plus R4 back to the battery. So current added up in a node, voltage adds up in a loop. So let's go through it. So total voltage, 16 plus 12, 28, plus 8 gives me 36 volts. Again, I didn't try and add that up in the table down here. I'm using the circuit to do that. It's a complex circuit, so I can't just jump to the table and say, oh, it must all be the same, or it's all added up or something. When it's a complex, you got to use the circuit and Kirchhoff's laws, the voltage and the current stuff, to help you get around and figure it out. Anyway, 36 divided by 4 gives me a total resistance of 9 ohms. All right. So that's kind of going through it. Showing your work would be fine if you showed it all up there. If you wanted to show me the calculations or kind of the reasoning for each one, you could do that as well. But that's the main thing with that complex. All right. So then we have a couple questions about the brightness of light bulbs and things like that. And then a little bit more on resistance. So as we kind of jump down this, I have 4 identical light bulbs, A, B, C, and D. And so we're just kind of asking what happens to each light bulb as we change some different things. So number 1, or just the first part of it, 9. If bulb A is removed, so if I remove this bulb, and I don't do anything with it, I just pull it out from the circuit and not replaced, which means I don't put anything in there, what happens to the current? Well, the current is no longer going to flow through here. However, because it's parallel, the current can still flow around this way. So it does not stop everywhere. It doesn't leak out. It doesn't decrease. It just continues through the remaining unbroken branches. It continues around through B and finishes off the circuit there. All right. Which 2 elements have the same magnitude of current? So again, back it up a little bit. So we put A back in there. Which ones have the same current? Now your initial thought would be, oh, A and B, they have the same. They're in parallel together. They would have the same voltage, but not the same current. C and D both have the same flow through them. They both have all the flow of the current. And so which 2 circuit elements have the same voltage drop? Well, there's the A and the B. The same voltage from here to here across A and B because they're in parallel with each other. And then if we were going to rank the brightness of the bulbs, brightness is current, how much current's flowing through each one. So the brightness would be, greatest brightness would be D equals C, because they're going to have the same but the most current. And then A and B are each going to have this current split. So they are not going to have as much current flowing through them. They're going to be about half the brightness of C and D. And so it would then be A equals B. All right. So thinking a little bit on resistance here to finish this off. So I have 3 resistors having the same value wired in parallel. How does the equivalent resistance compare to the resistance of a single resistor? Remember, in parallel, it's always going to be less than any one of the resistors. So let's see, the equivalent resistance is triple the value, so it's definitely not going to be more. The equivalent resistance is the same. Nope, it's going to be less. The equivalent resistance is 1/3. That might work. And the equivalent resistance is greater than that of the single. That doesn't work. So without even knowing that it would be 1/3, I know that it's going to be less than any one of the resistors, and that is C. Because they're all the same, though, it would be exactly 1/3. All right. The resistors 3, 6, and 12 are connected in series. What's the equivalent resistance? So this is a total is just R1 plus R2 plus R3. So I'm just doing 3 plus 6 plus 12, and I end up with, what is that? 9, 12, 21? Yeah, 21. There it is, 21. 21 ohms. All right. If I then connect resistors in parallel, but notice it's not the same number, so we got to do it a little bit differently. This one is going to be 1/4 plus 1/6 plus 1/10, all to the -1. And if you do that out, it comes out to be 1.9. Is that an option? Sure enough. C right there, 1.9. And a check is that it's less than any of those resistors. 1.9 is less than 4, it's less than 6, and it's less than 10. So that's a good idea that we did it right. All right, 2 resistors with 6 and 12 are connected in parallel. This combination is connected in series with a 2. What's the equivalent? All right, so we've got a 6 and a 12, so 6 and 12, and then that is in series with a 2. So here, I'm going to have to kind of put them together. So I got to put the 6 and the 12 together, and then I have to add it to the 2. So 6 and 12 is going to be 1/6 plus 1/12. all to the -1. And that gives me 4 ohms. And then I'll do 4 plus 2 to give me 6 ohms. So it is B is my 6 ohms. Right? And then finally, 2 resistors with 6 and 12 are connected in parallel. This is connected in series with a 2 and an 18-volt battery. What's the current out of the battery? Well, I don't need to redraw this or anything. It's the same description. So I basically have, despite that description, I basically have an 18-volt battery connected to a single 6 ohm resistor. And so V equals IR tells me that 18 equals current times 6. So I is just 3 amps. And that's it. I apologize for this taking so long to get all these videos out to you, but the key is finally finished and videos are made. And again, email me with any questions. I'm available before school tomorrow and I'm available first period tomorrow. Happy to help anybody that I can with that, with the work. Have a good one and hopefully see you then.